Hello students, in this lesson let us discuss about the testing of limes. So basically the first 5 tests we will be discussing here. The first test is the visual inspection. So the name itself is indicating that we just see the lime and do the inspection for examining its color and for lumps. Okay, so if the color is white, that indicates that it is a pure or fat lime. And if there are lumps of lime, then it indicates that it is either a quick lime or unburnt lime. So if during the burning process there is lot of raw material which has not been burnt to form lime, then that particular lime is called as the unburnt lime. Okay, so this is what we do in the physical or the visual inspection. Next test is the field test. Now under field test we have different tests that we have to conduct. Okay, so the first test is the test of physical properties. Now what are these? Suppose it is a hydraulic lime, then they will be normally bushy gray or bushy brown or dark colored. And also the hydraulic limestone what we take for the manufacture of the lime, this will generally be very clayey in taste, and also it will give a very earthy smell when you smell it. Okay, suppose the lime is white in color. Now what does that indicate? It indicates that the variety of the limestone what we have is of its purest form. So pure variety of limestone. And if suppose on the limestone we have some shiny particles on the surface, so these particles what I'm showing is huge, just for your reference I'm telling. So if they have any kind of shiny particles on the surface, then it indicates the presence of free salt in the lime. Okay, so this all are the physical tests which you can perform. Moving on to the workability test. Now how do you do it is, you take a handful of mortar. Okay, so the mortar will include what? This is nothing but the lime sand mortar, which will be in the ratio of 1:3. Okay, you take this and throw it on the surface on which you want to use the limestone. Okay, so when you throw it, suppose this is the surface on which you want to use this lime. So you throw this mortar and you just check how much of area is covered by this mortar. Okay, along with area covered, you also measure the quantity. So this will help you how much of area covered and how much of quantity is required. Will try to help you know the workability of the mortar. See, this is a very crude field method which you are going to apply, field method or field test which you are going to apply to know the workability. Okay, then moving on to the next test, it is the impurity test. What we do is we take a known weight of lime and mix it with the water in a container, or you can take a beaker and mix it. Once we do it, we decant the solution. Whatever is this solution we obtained, that we are going to decant. Now, once we do this, what we do is we take the residue and dry it for about 8 hours in the natural sunlight. We are not going to do any oven dry here. We are going to just in the natural heat of sun dry it and then take the weight. Okay, I'll call this weight as W1. So if in case this residue is less than 10% of the initial weight is this known weight of lime what we have taken, that is the capital W. So if it is less than 10% of its initial weight, it is considered to be a very good quality of lime. Suppose it is between 10 to 20%. The type of lime which we have here is the fat lime, and if it is greater than 20%, then the type of lime is of a very poor quality. So this is how we check the impurity of the lime. Moving on to the last test here in this slide is the heat test. So what we do is we take the limestone and then heat it for 4 hours, and this heat should be done in the open fire. So what will happen when we do this is your CO2 will escape and your limestone will lose its weight. So once it loses its weight, if we know the initial weight and the amount of weight that is lost, okay, we can take it as delta W. We can work out on the carbonate percentage which is there in the limestone. Okay, so after that we can check the texture of the limestone which has been heated. Suppose the texture is remaining lumpy, or if a lumpy form is there, then it indicates that you have a lot of quick or unburnt lime. And suppose you have a very porous structure or porous form, then it indicates that you have just the quick lime. Okay, so this is about the heat test. Moving on to the next test is the hydraulic acid test. Now, why do we conduct this test is to know the classification of the lime. So under which category our lime is going to fall. To know that, we are going to conduct this test. No classification of lime. Also to know the carbonate content of lime. So what we do here is we take a teaspoonful of lime and we put it in a test tube which is containing about 10 ml of 50% hydrochloric acid. Okay. Now when we do this, the efflorescence will take place in the lime. If your efflorescence is too much or very high or too much, then this will indicate that there is a very high percentage of calcium carbonate in the limestone. And whatever is the residue that we find in the bottom of the test tube, that indicates the presence of the inert materials which is present in the limestone. So residue at the bottom of test tube indicates what? Percentage of inert materials. And if there is very abundant liberation of CO2, abundant means what? More or unexpectedly very high. Abundant liberation of CO2 indicates unburnt lime. Okay, so there is some more points to this test which we have to understand. If it is a class A lime, a very good layer of gel will be formed, and this gel will be above the layer of the inert material which is there, okay, under the test tube. So this is good gel. Suppose it is a thick gel layer, then it indicates class B lime. And if there is absence of gel, then it indicates class C lime. Right. There's one more understanding. So for if you have a very eminently hydraulic lime, then the gel layer will be very thick and it will not flow. Also, the absence of gel will sometimes indicate that it is a non-hydraulic or a fat lime or non-hydraulic lime. And suppose if the gel flows, then it indicates a feebly hydraulic lime. So this is all about the hydraulic acid test of the lime, which comes under the field test. Now the last one in the field test is the ball test. What we do is we will make balls of very stiff lime paste and we will leave it for about 6 hours. Then what we do is we place them in a basin which contains water. Suppose there is expansion of the size of these balls or there is disintegration. Disintegration is what? Suppose the balls have fallen apart. That is called disintegration. If you observe this, this is class C lime. And if there is very little expansion and only cracks are formed on the surface of the lime, then it is your class B lime. And if there is no adverse effect of water on these lime balls, then they come under class A lime. Okay, I hope these tests are clear. Moving on to the next test, it is the physical test. See, generally what we have to do is the sampling of testing lime should be done as quickly as possible so that the material does not deteriorate. We should not allow the lime to deteriorate. Okay. So from each lot, that is from, see, the lot sizes for doing this physical test are like this. So one is up to the 100 tons. Next one is between 101 to 300 tons. Next one is between 301 to 500 tons. And next one is between 501 to 1000 tons. So what we have to do is we have to take 3 test samples. Sampling should be done as quickly as possible. Very important thing to be remembered. So what we have to do, take 3 test samples from each one So you take it both from the quicklime as well as the hydrated lime. The sample size for quicklime is what is shown in the table. So this is only for the quicklime. A similar thing we have to do it for hydrated lime also. In quicklime also we have lump quicklime and we have powdered quicklime. If it is lump quicklime, you have to take it in this order, and if it is powdered, you have to take it in this order. For hydrated lime, it should never be less than 5 kg. You have to remember. Okay, so this is how you do the physical test so that that doesn't get disintegrated. The next test is the fineness test. Now this fineness test is done according to the IS 6932 part 1V. So what we do here is we are going to arrange all the sieves one on top of the other. So we take the coarser sieves on top. This is your top, and the finer sieves on the bottom. So after this, we have to do the sieving with a very gentle wrist motion. Okay, so whenever we are doing the sieving, we have to make sure that we are doing it very gently. Now what the content what we have to take is 100 grams of hydrated lime. Okay, we place it on the topmost sieve and is washed through the sieve with the help of a modern jet of water or a moderate jet of water. We have to use the moderate jet. It should not be too slow or it should not be too fast. Now this jet of water should be continuously poured on this. The amount of time should not be less than 30 minutes. We have to make sure that more than 30 minutes we have to put this water. Right. Now what we do is we take the residue on each sieve. It's very important to take the residue on each sieve and then oven dry them at 100 plus or minus 10 degree centigrade and then take the weight. Once we do this, we express the results in the percentage of mass of hydrated lime taken. So the total hydrated lime what we have taken was how much? 100 grams. So this is how you can do the fineness test. Now the last test in this particular video or the lesson is the determination of residue on slacking of quick lime. Now this is done according to the code IS 6932 part 3. What we do is we take a sample of quicklime and sieve it through 2.36 IS sieve, and if there is any residue, we just break this residue and then sieve again until this whole quantity passes through the sieve. Okay, now once we do this, we have to see basically why we are doing this is to remove the lumps. Remove the lumps. After this, we have to use certain quantity of water to slack the lime. Basically, we are doing slacking here, right? Slacking is nothing but adding water to the lime. So how much of quantity of water should be added is also specified. So generally we need 4 times of the mass of quicklime what we have. But it is not restricted to this. It may be as high as 8 times also. Suppose if it is a high calcium lime. So it depends upon what lime we are taking. Minimum we have to choose this, and based on the slacking condition we can fix it. So whenever the slacking temperature is specified by the vendor, the temperature of water is to be adjusted. Okay, we have to adjust whatever they give the temperature. No, for that we have to adjust. It can be plus or minus 2 degree centigrade, no problem. And then what we do is we add 5 kg of quicklime sample. And when we are adding this, we have to make sure that we add it in small quantities. Okay, and within 5 minutes you have to add it. Add in small quantities. So during this operation, what we have to do, the mix should be stirred continuously. We cannot stop stirring. Okay, continuously we have to keep on stirring the mixture. Also, we have to make sure we are maintaining this temperature for about 1 hour. Then we allow the product to stand for 24 hours from the time the quicklime is added to the water, and is allowed to cool gradually to the room temperature. During this period of 24 hours, the lime will come back to room temperature, which is around 27 degrees centigrade. And during this entire 24 hours, we have to make sure that we at least 2 times stir the mixture. Okay, and when you're doing the last stirring, you have to make sure that you're stirring it 1 hour before this 24 hours. So the last stir can be done at 23 hours, but not later than this. Next, what we have to do is we have to sieve this mixture. Now this mixture is generally called as the supernatant liquid. Now whatever is the remainder, once we do the sieve, we have to again stir it, and we have to pass it through the 850 micron IS sieve, and after that pass it through the 300 micron IS sieve. Right, we fit a very temporary filter cloth to the vessel in which we are going to sieve it. Okay, so whatever is the content in the slaking vessel, we will transfer it onto the sieves by washing the vessel with a jet of water. Once we do this, whatever is the residue which is present, we are going to wash it and dry it at 100 plus or minus 10 degree centigrade to a constant mass. So there are two sieves now, right? This as well as this. So the residue on each sieve will be weighed separately, and we report them in the form of percentage of quicklime taken for the test. Okay, so this is how you do the determination of residue on slacking of quicklime. Now one important note which you have to make here is, I told you we have to keep it at a temperature what vendor gives us, right? Sometimes if the vendor has not specified the temperature, we have to maintain it at about 50 degree centigrade, one sample, and the other sample can be kept at 100 degree centigrade. Now this both can be plus or minus 2 degree centigrade. Okay, only if it is not specified by the vendor. So I hope the lesson is clear. There are some more tests which we'll be seeing in the next lesson. Thank you.